All right, so in this video, the goal is to show you how to determine where you have partition numbers after you have the derivative. And this is just going to highlight three problems from the review sheet, number 4, number 5, and number 10. The reason I'm doing that is because those are the ones that are a little bit trickier, and they have some things that students often mess up when they are setting the derivative equal to 0 and undefined. So the number one mistake here is students will just go ahead and set this equal to 0. While that's not entirely incorrect, you do want to find where the derivative is 0 and undefined to find your partition numbers. However, if you do that right here, you're probably going to make a mistake because of the negative exponent. So let's start by remembering that anytime you have a negative exponent, go ahead and put that in the denominator to make setting the derivative equal to 0 and undefined a little bit easier. So let's start there. Now be careful, the only thing that's raised to the negative 2 power is the variable, so the 4 stays on top. So it's 4 over x squared. Now, the next mistake that students make is they just simply set this equal to 0. And if you do that, you will get 2 of your 3 partition numbers. You will get negative 2 and 2 if you just go ahead and set this equal to 0 right now. Because you would then, take this to one side, cross multiply, and you would get x squared equals 4, and you would get 2 of your partition numbers, 2 and negative 2. However, you would miss one of your partition numbers likely because you are not that likely to realize that the derivative is undefined at 0. And that's because if you plug 0 into this denominator, you're going to divide by 0 and get undefined. So the better thing to do is if you have any type of fraction in your derivative and you're adding or subtracting another number, is to get a common denominator and make it one fraction. So this is really easy because your first number is 1. So to get a common denominator, you're just going to multiply 1 by x squared over x squared, right? Or just make 1 x squared over x squared. So we're going to get a common denominator here by making 1 x squared over x squared minus, and then we have our 4 over x squared. And then we're going to go ahead and make it one fraction. So the derivative is equal to x squared minus 4 over x squared. Now we can go ahead and easily find our partition numbers. So if you recall, your partition numbers are where your derivative is 0 and also where your derivative is undefined. Okay, so my derivative is 0 when the numerator of the fraction is equal to 0. So x squared minus 4 equals 0, x squared equals 4, and then we get x equals plus or minus 2. That's another place that students make mistakes, is when they take the square root of 4 or any square root, they forget to write plus or minus. So here's 2 of my partition numbers, and then I'm also going to determine where my derivative is undefined. And so that means I'm going to set the denominator equal to 0, take the square root of both sides, I get x equals 0. So my partition numbers are x equals 0, x equals negative 2, and x equals 2. Now, to make our number line, we don't actually even care if these are critical values yet, because when you make your number line for your derivative, you always include all the partition numbers, whether they are critical values or not. So I'm going to go ahead and put all 3 partition numbers on there. The other thing I'm going to do is I'm going to rewrite my derivative in factored form so that it's really easy to make a sign chart off of. Now the cool thing is my denominator is just a variable squared, so the denominator is always positive. So really the only thing we care about is the numerator. So I'm going to go ahead and just kind of throw the signs on here. It's plus, minus, minus, plus. Okay, so now the only thing that could happen here, right, is that negative 2 could be a max because my derivative is going from positive to negative, so my function's going from increasing to decreasing, and 2 could be a min. We just have to make sure that neither of these, negative 2 and 2, make the original undefined. So if you look at the original, and I don't have that here because I just started with the derivative, but the original is x plus 4 over x. If you plug in negative 2 or 2 into this, you don't get undefined. So my critical numbers, sometimes you'll see them called critical values or CV, my critical numbers are 2 and negative 2, but 0 is not a critical number because if you plug 0 into the original, you get undefined. So my partition numbers, there are 3 of them, but my critical numbers, there are only 2. Now, since my derivative switches signs at -2 and 2, we have relative extrema there because they are critical numbers. So finally, x equals -2 is a relative max, and x equals 2 is a relative min. And that's how you do that problem. So the next problem that I'm going to do is number 5. So if you don't need help with number 5, you can fast forward the video and just go to the next problem that you might need help with. I'm going to do number 10. So if you don't need help with number 5, go ahead and skip this part of the video. I'm going to go right to the derivative. So in number 5, the derivative is 2/3. You have to use the chain rule. So 2/3 times x squared minus 4 to the -1/3 times 2x. So that's my derivative. Now, we have a negative exponent. So let's do what we said in the last problem, and let's get that negative to the denominator. So we're going to get f prime of x is equal to 2 times 2x is 4x, and then my denominator is 3 times x squared minus 4 to the 1/3. Now, it's super easy. When is my derivative 0? Well, that's when the numerator equals 0, and that's x equals 0. So that's my first partition number. Let's go ahead over here. We'll put our partition numbers. And then when is my derivative undefined? Well, that's when the denominator is equal to 0. So I'm going to divide both sides by 3. And then to get rid of the cube root, I'm going to cube both sides. So I still get 0. And then I'm going to add 4 and take the square root, so then I get x equals plus or minus 2. So these are all of my partition numbers. So I have 3, okay? Now again, we don't even care yet if they're critical values because we're just making a sign chart for the derivative. So -2, 0, and 2. So here's my derivative, okay? If I put in -3, the top's going to be negative, and the bottom's going to be positive. So it goes, let's see here, negative, positive, negative, positive. Okay, so now we have to check to see what is a critical number before we find our relative extrema. If you look at the original, which I don't have written down on here, it's a cube root squared. Well, you can take the cube root of a positive or a negative. So it doesn't matter, like none of that is undefined. And then if you square a positive or a negative, it's not like that will ever go undefined. So our original is never undefined. So these are all also critical numbers. Okay, so that means since we go from a negative derivative to a positive derivative, that's a relative min at x equals -2. We have a relative max at x equals 0, and then we actually have another relative min at 2 because we go from decreasing to increasing. So decreasing to increasing, increasing to decreasing, and decreasing to increasing again. Whoops, I hate when that happens. Like that. Okay? So that's my answer for number 5. And the point of that one was anytime you have a negative exponent, put it in the denominator. All right, so the last one I'm going to do is number 10. And number 10 deals with GCFs. So let me just move some things out of the way so I can get a new page. Everything is in my way. Hold on one second. Here, wait. Give me 1 second. Sorry. I'll pause the video until I can get a new page, and then you don't have to sit here and listen to me figure out how to do that. Okay, so I figured that out, and I also wrote the derivative for number 10. So in number 10, you have to use both the product rule and the chain rule. So there's the derivative. I'm going to clean this up a little bit, and I'm just going to kind of multiply some stuff out. So what I mean is I'm going to bring this 2x in front because it just makes a little bit more sense to me that way. And then over here, I'm going to do 2 times 2 and get 4. And then I have my 2x minus 1, and then x squared minus 9. Now, you don't actually have to do that step, but it's a little bit easier for me. I don't know if you did this problem by multiplying it out, but I know at least one student did. If you do that, you get a cubic that has 4 terms and doesn't factor. So it's actually pretty confusing. So what you have to do here is actually take out a GCF. So if you try to find your partition numbers, we want to know where the derivative is 0 and undefined. So this is never going to be undefined, but where it's 0, we're going to factor out a GCF. Now, if you want to take out a 2, because both of these sides are divisible by 2, because you have a 2x and a 4, so we could take out a 2, and then they both also have a 2x minus 1, but that's all they have in common. And then what do you have left in this first term? Well, you took the 2, you have an x, and then you have a 2x minus 1. And then in the second term, I took 2 from the 4, so I have 2 left. I took the 2x minus 1, so I still have the x squared minus 9. So I just factored out a GCF. And like I said, if you try multiplying this out by foiling and everything, you end up getting something that you can't factor. So you really should try to use the GCF. So we get 0 equals, and then all we have to do to use the 0 product property is get the inside of these brackets cleaned up. So x times 2x is 2x squared. X times negative 1 is negative x. Plus, and then 2 times x squared is 2x squared, and then minus 18. All right, so we get 0 equals 2 times 2x minus 1, and then 2x plus 2x is 4x squared, sorry, and then we have minus x and, minus x and minus 18. So now we can go ahead and use the 0 product property to figure out what values of x make our derivative 0. So 2 equals 0 doesn't do anything because it's just a number. If we get 2x minus 1 equals 0, then our first partition number is x is a half. Then we got to factor this guy to set him equal to 0, right? So 4x squared minus x minus 18 equals 0. Factor that however you factor. Hopefully it's guessing and checking. It's 4x and x that work. And then, let's see, I think it's minus 9 and plus 2. So that's negative 18 minus 9. Yeah, that works. So we get 4x equals 9, or x equals 9/4. And this guy gives us x equals negative 2. So our partition numbers are x equals 1/2, 9/4, and negative 2. And then if you look at the original, which like I said, I don't have on here, but if you look at the original, it's not undefined anywhere because it's a polynomial. So actually all of these are also critical numbers. And then if you make your sign chart for your derivative, the only thing I would suggest with that is putting it in the most simplified version. So let me get these here, and then I'll go grab the derivative. And like what I mean is, it might be easier to substitute these in your derivative instead of substituting numbers into there. So if you look at your derivative, let me change colors here, as this. So it would be, let's see, I think I took a 2 out, right? So 2 times 2x minus 1, and then 4x minus 9, and then x plus 2. That might be easier to do a sign chart with than this version, right? So if you do the sign chart, it goes negative, positive, negative, positive. So what that means is we have a relative min at x equals negative 2 and 9/4. So we have 2 mins. And then we have a relative max at x equals 1/2.